Hello everyone. This is a video where we will do some quick power calculations in a circuit, and it's actually our very first example in this area, so we'll go here step by step to understand how to calculate power. So here's a simple circuit we're going to look at. This circuit is excited by a DC voltage source, a direct current voltage source. We'll talk about DC sources later on in more detail, but this is nothing else than a battery. So here's a 15-volt voltage source, and then we have two devices A and B. We really don't know what these devices are, except that we do understand that these are loads. So first of all, let me say a couple of things. When we say that a device is a load, we truly mean that this device is consuming electrical power to do something useful. For example, if these devices were heaters, they would be using electrical power to generate heat. If these devices were machines, they might be using electrical power to move something. It could be motors, for example. At any rate, these devices are simply consuming electrical power. So as far as we're concerned, these are called loads. Similarly, sources generate electrical power, as we have seen before. So the first load, load A, is consuming 3 watts, and load B is known to consume 12 watts. Now, what we would really like to do here is find the current I that flows in the circuit. We really don't know many laws that govern circuits today. For example, we haven't covered even Ohm's law yet, or we haven't covered Kirchhoff's laws yet, so we can't really work with those to solve our circuit. However, there is one fundamental law that we do know, and this is the conservation of energy law. The conservation of energy basically says that as long as you have a closed system, the amount of power you generate in that system must be equal to the amount of power that you consume in that system. And in this class, we're going to assume that our circuits are closed systems. So the energy must balance. The generated energy must be equal to the consumed energy. So if I look at this circuit here and I ask the question, what is my total consumed energy? Then I would look at that circuit and I will say, well, the two devices that consume energy are loads A and B, and that means that the total consumed energy should be equal to PA plus PB, or 15 watts. That energy must be provided by somebody, and the entity providing this energy here is this 15-volt voltage source. And if I ask the question, how much is the energy that this voltage source delivers to the circuit, this number will be equal to V times I in the active convention. And as you can see already, this source, by the assumed direction of the unknown current I, is actually in the active convention. So that means if I multiply the 15 volts that this source has across its terminals with the current I in the assumed direction, I should be able to get correctly the delivered energy by that source. Now, I just mentioned that based on the conservation of energy, these two quantities should be the same. So that means that the current I will be nothing else but 15 watts divided by 15 volts, or simply 1 amp. Notice that if I had assumed the current to flow in the opposite direction, I would have simply found a negative 1 amp here, which would have meant that the true current is 1 amp in the opposite direction. Nevertheless, I assumed current I as shown in this figure, so I found the current I to be 1 amp, so the first part of the question is done. The second part of the question asks to find the voltages V1 and V2, or more precisely, to find the voltage difference across the device A and the voltage difference across the device B. Well, we can again solve this problem from an energy or power point of view. The power consumed by load A should be equal to the voltage difference across its terminals, which is here indicated as V1, times the current I that flows through this load A, provided that I have passive sign convention. Because if I don't, then this V times I is not equal to my consumed power. It would have been equal to the delivered power. So let me check the schematic. Is my load A in the active sign or the passive sign? The current I flows through this load from its positive terminal. So indeed, I have passive sign convention, which means that V1 times I indeed will give me the power consumed. So from here, I can say that V1 is equal to the 3 watts that this load is consuming divided by the 1 amp that I have flowing, or simply 3 volts. In a very similar way, I can find out that V2 it will be equal to the 12 watts that this device is consuming divided by the 1 amp, or simply 12 volts. Notice that my second load is still in the passive sign convention, since the current I is flowing into the load from its positive terminal. So both from loads A and B, I have the passive sign convention, and the result is the one that you see here. So this is the end of my first example, and as always, I do encourage you to go ahead and repeat this yourself and make sure that you get the same results. Thank you.